Hello to everyone. In this video, let us discuss introduction to chemical bonding and types of chemical bonding and especially ionic bond. Okay, first, what is the meaning of chemical bonding? So listen here. For example, if you consider atoms, they are highly energetic in nature. Now atoms will combine to give a molecule. By losing some energy in that process, they get the stability. So like that here, to get the stability, atoms combine with one another and give a molecule. So now in between atoms, there is some attractive force is there. So that attractive force bind two or more atoms or ions in a molecule or in a ion is known as which one? Chemical bond. So some attractive force bind that two atoms or two ions together. That type of force of attraction is known as which one? Means chemical bonding. So what is the need to participate in chemical bonding for atoms? Means all atoms are having which one here? High energy, means less stability. So by participating in a chemical bond, they loses some energy and get into the which one? Stability. Okay, then, and in periodic table some elements are there. They are highly inert to participate in bonding. Which elements those are? Inert gases. In inert gases, except helium, remaining all gases are having 8 electrons in outer shell. 8 electron configuration is called octet configuration. So like that here, due to octet configuration, except helium, of course, all are having octet configuration. Due to that, they are having which one? Means stability. So now here, the remaining elements also try to get this octet configuration. So the phenomena of that atoms try to get which one? Get into that octet configuration, that is known as octet rule. So as per octet rule, the atom which is having 8 electrons in outermost shell, that atom will become stable. So now how they will get into this octet configuration? No problem in that. What is the process here? Either by losing or by gaining or by sharing electrons, all the atoms try to get into octet configuration. So in that transfer of electrons or sharing of electrons, some bonds are formed in between atoms. So now here, now that process of bonding is explained by which one? Means here electronic theory of valency. So Lewis and Cossel proposed this electronic theory of valency. So what are the statements? What are the statements in electronic theory of valency? Let us see here. Now the first one is here, the electrons present in outermost orbit known as valence electrons. Electrons present in outermost orbit are known as valence electrons, and electrons present in inner orbits are known as which one? Core electrons. So except valence electrons, the remaining inner orbit electrons are called core electrons. Now that core electrons plus nucleus, these combinedly called as kernel. Nucleus plus core electrons, except valence electron, the remaining part of the atom including nucleus is known as kernel. Only valence electrons participate in bonding. Valence electrons participate in which one? Means bonding. Core electrons they do not participate in which one bonding. And the atoms which are having 8 electrons in outermost shell, they get the stability, and that is called octet configuration. All the atoms, either by losing or gaining or by sharing electrons, get into octet configuration, and they get the stability. So this is the theory known as which one? Electronic theory of valency. Okay, then after this, let us see one example here, formation of bonding in between two hydrogen atoms. Hydrogen and another hydrogen atom will combine to give which one? H2 molecule. Here delta H value is minus 435 kilojoule per mole. That means when hydrogen molecule is formed from its constituent atoms, this much energy is liberated out. That means by losing this much amount of energy, two hydrogen atoms combining to give H2 molecule. So now comparatively these individual atoms, H2 molecule is having more stability. Okay, now let us see the types of chemical bonding. So what are the types of chemical bonding means? Majorly two types of bonds are there. First one is ionic bond. Second one is known as covalent bond. Of course, dative bond also there, but majorly two types are here: ionic bond and covalent bond. So now let us see which one here, ionic bond. So what is ionic bond means here? The bond present between, the force of attraction present between two oppositely charged ions. The electrostatic force of attraction present between two oppositely charged ions is known as which one? Ionic bond. So now here, in regarding ionic bond and covalent bond, we have to learn one important property. What is that means? Electrovalency and covalency. So already we learned to valency. Valency means that the number of hydrogen or chlorine atoms are twice the number of oxygen atoms with which an element is bonded is known as valency. Now let us know what is electrovalency. Electrovalency related to ionic bond, the number of electrons lost or gained by an atom to form ionic bond is known as its electrovalency. See here, to form NaCl, sodium lost one electron to form Na plus. So electrovalency of sodium in NaCl is 1. And here chlorine gained one electron to form NaCl. So in NaCl, chlorine electrovalency also 1. Now if you come to MgCl2, in this magnesium is present in +2 state and chlorine present in -1 state. So electrovalency of magnesium is 2 and electrovalency of chlorine is 1. So in AlCl3, aluminium forms Al plus 3 by losing 3 electrons. So electrovalency of aluminium is 3 and chlorine electrovalency is 1. So this is regarding which one? Electrovalency. Okay, now let us see one example, formation of ionic bond with an example of which one? NaCl. So in that first, let us consider sodium here. Its atomic number 11, configuration neon 3s1. But sodium is not having stable configuration because it is not having inert gas configuration. Then by losing one electron, sodium forms Na plus and gets into which configuration means neon configuration. So like that, by losing one electron, sodium forms Na plus. The electron lost by the sodium now gained by the chlorine, and chlorine atomic number 7, its configuration neon 3s2 3p5. So by gaining one electron, chlorine get into which one? Argon configuration. So like that, by losing one electron, sodium got stable octet configuration. By gaining one electron, chlorine also got stable octet configuration. Now in between Na plus and Cl minus, a strong electrostatic attraction is present that will bind the two oppositely charged ions together. That bond is now called ionic bond. So like that, NaCl molecule is formed. Okay, this is the example for formation of which one means ionic bond. Now let us see here what are the favorable factors for the formation of ionic bond. So some favorable factors should be there for the formation of ionic bond. So already we discussed here, for the formation of NaCl, we have observed that Na plus formation and Cl minus formation. That means ionic bond formation occurs only after the formation of a cation and anion. So like that here, favorable factors for ionic bond is again of two types. That means in that two categories are there. In that first one, favorable factors for the formation of cation. So let us see what are the favorable factors for the formation of cation. And before going to that explanation, one important thing here, how much easily a cation is formed and a anion is formed, that much more ionic nature present per that pair. So ease of the formation of a cation and anion increases, the ionic nature of the compound formed from that also increases. So we have to remember that thing. So easier is the formation of cation and anion, greater is the ionic nature. That is most important thing we have to remember. Now let us see the favorable factors for the formation of cation. So we know that to form a cation, any atom try to lose electron. So all our factors to be in favor of losing electron only, because as much easily an atom loses electron, that much easily cation is formed. So now first regarding which one, atomic size. So we have to expect here which atom, let it be the A atom, let it be the B atom. Here electrons are present in outer shell. So we can expect here which of these two atoms will lose electron readily means B atom. That means why here electron is away from the nucleus means nucleus is having less attraction on that electron. So now comparatively B loses electron readily. So what is the first favorable factor means here? Larger atomic size. So as the atomic size increases, ease of formation of cation also increases. Now regarding ionic nature, one question here. Lithium chloride and rubidium chloride, which is having more ionic nature? That is the question. Of course here anion is same, that may not, no need to concern anion to decide its ionic nature, because in these two same anion. Now consider the cation, lithium and rubidium. In between these two, rubidium is having somewhat larger atomic size. So favorable factor for cation is for which one means rubidium. So now rubidium chloride is more ionic in nature. Lithium chloride is less ionic. Less ionic means more covalent in nature. So it is more covalent, less ionic. Rubidium chloride is more ionic, less covalent. Okay, now second favorable factor regarding ionization potential. Let us see which IP favors formation of cation. IP means the energy required to remove the electron from outermost orbit of an atom is known as ionization potential. So for example, A atom ionization potential 600 kilojoules, B atom ionization potential 100 kilojoules. So that means to remove the electron from B, just 100 kilojoule is enough. But in case of A, we have to need to provide 600 kilojoule. That means in between these two, B easily loses electron and readily forms the cation. So that indicates what here? The second favorable factor is low ionization potential for the formation of cation. And come to the third favorable factor. So what is third favorable factor means? Regarding charge. So which charge should present on cation? That means high charge or less charge should present on ion. Let us see here. Come to the example here, Na plus, Mg plus 2 and Al plus 3. Now for the formation of Na plus, just it is required to removal of one electron. But for the formation of Mg plus 2, we need to remove the 2 electrons. That means we have to go for IP2, second ionization potential. And in case of Al plus 3, to remove the 3 electrons, we have to move up to IP3, third ionization potential. But removal of successive electrons from an atom, and after one by one electron, it becomes more difficult. So like that here, that means why here IP1 less than IP2 less than IP3, like that. So now removal of electron from cation is difficult. As positive charge on cation increases, that ionization potential value increases much and more. Why here? As the number of electrons decreases, nuclear attraction dominate over the outermost electron. So like that, successive removal of electrons causes that which one increase in ionization potential. So that means Na plus is formed easily, Mg plus 2 somewhat difficult, Al plus 3 much and more difficult. So low charge on cation is the favorable factor for the formation of which one means low charge is favorable factor for the formation of which one? Cation. And that cation, if present in an ionic compound, that is having more ionic nature. That means the question here, NaCl, MgCl2, AlCl3, which is more ionic in nature. As Na plus formed easily comparatively with Mg plus 2 and Al plus 3. Now NaCl is having high ionic character, AlCl3 is having high covalent nature. So this is the third favorable factor. Now come to the fourth favorable factor, formation of cation with inert gas configuration. With inert gas configuration, if cation is formed, that easily that process will take place. So for example, if you come to which one? K plus and another one Zn plus 2. K plus is having argon electronic configuration. That means inert gas configuration. But Zn plus 2 is having nickel group configuration known as pseudo inert gas configuration. But comparatively with pseudo inert gas configuration, inert gas configuration is more stable. So now K plus formed easily comparatively with which one means Zn plus 2. So these are the favorable factors for the formation of which one? Cation. Now let us see favorable factors for the formation of anion. So anion, how it is formed means by gaining one electron, we know that anion is formed. So now what are the favorable conditions? Let us see here. First one, smaller atomic size. As atomic size decreases, that atom can gain electron easily. So like that here smaller atomic size is favorable factor for the formation of anion. How easily anion is formed, that much greater ionic nature is present. So NaF and NaI, which is more ionic in nature. Now here sodium is common in both components, no need to that concern that. Come to fluorine and iodine. As fluorine is having smaller atomic size, it easily form anion. So NaF is more ionic in nature, but NaI is less ionic and more covalent in nature. So this is the first favorable factor. And second favorable factor is smaller charge or less charge on anion. Less charge on ion. So why less charge we need here means, for example, if you want to prepare F minus, just by adding one electron to F, we get F minus. But if you want to get O minus 2, first we have to add one electron to oxygen to get O minus. Then again by adding another electron, we get O minus 2. But here addition of electron, negatively charged electron to O minus is difficult. So F minus is formed easily comparatively with O minus 2. So anion also should have less charge, then it we can expect the formation easily and having more ionic nature. Now example here, NaF and Na2O, which is having more ionic character means NaF, because F minus formed easily, and Na2O is having more covalent nature. And third favorable factor is high electronegativity and electron gain enthalpy or electron affinity. So the atoms which are having high electronegativity or and also high electron gain enthalpy, they readily form the anion and having the greater ionic character. So these are the favorable factors for the formation of ionic bond. Okay, bye.